Hello friends, this lecture will be an introduction to the topic of degrees of freedom and constraints. Now, as we have seen in the previous lecture that essentially for a planar rigid body like this, which moves basically in a 2D plane, you have got 3 degrees of freedom. There are 2 independent translations, that is one translation about x-axis, one translation about y-axis, and there is one rotation about the third axis, that is the z-axis. So, a 2D body or a rigid body moving in a 2D plane has basically got 3 degrees of freedom. Right. Now, the next thing that we are going to do is, we are going to find out if there suppose there's a system of body like this. This is one rigid body and this is another rigid body. This is suppose A and this is B. So this body A has 3 degrees of freedom, this body B has 3 degrees of freedom. So essentially both of this, to define the displaced geometry of both this body with respect to again a fixed frame. This is pretty important, that we need to define a frame such that if suppose this is one body, this is body A and this is body B, and body A and body B moves such that there is no motion between body A and body B, but with respect to a frame there will be some motion between A and B, or there will be motion, A will be under motion and B will be under motion. So basically if you have this frame and there is one body A, one body B, to define the complete displaced geometry of these 2 bodies in this frame, we have 3 degrees of freedom that we need for A, we need 3 degrees of freedom for B, and essentially we got to have 6 degrees of freedom to define the complete displaced geometry of this 2 bodies. Now essentially if we see that there can also be situations wherein this A, suppose this is body A and this is suppose body B, and this body A and this body B are connected by some sort of a pin support, right? Pin. Now what happens basically is that how many degrees of freedom? There are 2 ways one can calculate the degrees of freedom. The first way is basically find out if in unconstrained state how many degrees of freedom both of this body have. A will have 3 degrees of freedom in unconstrained state, B will have 3 degrees of freedom also. So essentially in unconstrained state it will have 6 degrees of freedom. Now if it's constrained, that is if there's a pin between A and B, then essentially what happens is B's 2 translations are somewhat arrested, because B's 2 translational motion, that is movement along X and movement along Y, are no longer independent variables, such that what I basically meant is that if B is to move in X direction, A will have to move also in X direction. If B is to move in Y direction, A has to move in Y direction. So essentially it doesn't remain some kind of an independent variable. So essentially B's two translational motion, that is motion along X and motion along Y, are arrested, and you got to minus then 2 degrees of freedom due to this constraint that I impose in the form of a P. In the form of a pin, 4 degrees of freedom basically are needed to define the complete displaced geometry of this kind of a connected connected system of 2 bodies. Now essentially we can do it by another method also. For example, A will have 3 degrees of freedom, right? No doubt about it. A will have 3 degrees of freedom. Now if I have B and pin it up with A, then essentially B cannot move. If I consider a fixed frame, then connected to a fixed frame like this, and A will not have any motion suppose in X, Y, or it will not have any rotational motion, and B is connected with A, then therefore B's 2 translation motion are itself arrested, and B will have only one rotational motion. So B will have one rotational motion, so 3 plus 1 is equal to 4. So this system of body has 4 degrees of freedom. So this is one method, this is one method, right? Now for example, if we do another thing, if we can place another body, C suppose, right? We place another body, C, right? Then what happens? Then C will have essentially again 3 degrees of freedom. So in this case what will happen? 3, 3, 3. In unconstrained state I will have 9 degrees of freedom. Now there will be a connection between A and C, right? And this connection between A and C, basically what it does is that it imposes certain restrictions on the movement of C, such that movement of C in the X or Y direction is arrested. So I have to impose minus 2 degrees of freedom here, right? And A is also connected with B, right? So essentially what happens is that B's translational motion along X or Y direction is itself arrested. So minus 2 degrees of freedom. So essentially if I constrain or if I pin it up and if I have the 3 bodies which are connected, then essentially I have 5 degrees of freedom. And this can be obtained by the number 2 method also, wherein this will have 3 degrees of freedom. Now if I have C, now if I fix this body A and I bring C and pin it up with A, then essentially C cannot move in X direction or Y direction as I am fixing this A up with this fixed frame. So essentially what C can do basically, C can rotate, right? So therein I have 1 degree of freedom for C in a constrained state obviously, and B will also do have the same thing. If I make this A and C some kind of a fixed frame, and what I do basically is that I pin it up or I fix it up with some frame, then B will not have any translation motion along X or Y, and it will also have 1 rotational motion, and that is 1. So essentially I have 1, 2, 3 plus 1 plus 1, that is 5 degrees of freedom. Now a civil engineering structure is mostly static. So what I got to do is that I got to see how many degrees of freedom one structure has. And essentially I am going to impose certain constraints or restraints or things like that. That essentially what it does is basically restricts this degrees of freedom and make this structure some kind of a static structure so that it cannot move. It cannot have any independent movement variables, right? So I need to impose constraints, and essentially I will take this as an example, a planar rigid body. Suppose this is some kind of a body, suppose, right? And this will have obviously 3 degrees of freedom. That is, it can move over X, it can move over X, it can move over Y, and it can rotate. So how can I constrain this degrees of freedom so that this structure is essentially a civil engineering static structure? First, let us do something. Let us spin it up, right? Let us spin it up and with respect to a fixed frame, right? And when I pin it up with respect to this fixed frame, then essentially, or hinge it up with respect to this fixed frame, what I'm doing essentially is that I'm not allowing movement along X direction, I'm not allowing movement along Y direction. So I'm constraining the 2 degrees of freedom. So essentially this one had 3 degrees of freedom, and by placing a pin, I can constrain 2 degrees of freedom. But still, it has got 1 degree of freedom. That is, it can rotate. The pin can, this body can rotate about this pin at A. So essentially, to constrain this degree of freedom too, so what we need to do is that we need to place some kind of support at this point also. And essentially, we place a roller support. A roller support is some kind of support that restricts movement along only one direction, and that is a Y direction, right? And movement along X direction is allowed, but movement along X direction is restrained at this point, so effectively it boils to nothing. So if it doesn't allow movement along Y direction at this point, essentially the structure will be some kind of static structure, because this rotation will also be arrested as this two pinned at these 2 points, right? So essentially I arrest this 1 degree of freedom also, and this thing becomes 0 degree of freedom, or essentially some kind of static structure. So this is all. I can also take an example of a cantilever like this. Example, I have again some kind of a planar rigid body like this, and it's built within the wall, suppose, right? Then what happens is that this planar rigid body can move about this direction. No, it can't, because it's built in within the wall and it's concreted or it's grouted, or there's some sort of adhesive which holds this planar rigid body and doesn't allow motion in this direction, right? It cannot also move about this direction because there is some certain kind of concrete or bricks, whatever be it, placed in on top of it or at bottom of it, so it cannot move in this direction also. Neither it can rotate, because there's some sort of a restraining moment that this thing gives. This connection basically, if this is my force F and this is my length L, so this gives some sort of a clockwise moment, and this connection, what it does is basically restrains this by putting some kind of a moment that is equal and opposite in nature to this FL. So if this is some kind of an element A and FL some kind of a clockwise moment, then this will create some kind of anti-clockwise moment, and essentially this thing will have no degrees of freedom. So this is all for this lecture. Thanks a lot for listening. Thank you.